Before creating custom annotations, let's go through some pre-existing ones, some of which you already know. Let's start with the famous override annotation. The override annotation in Java indicates that a method is being overridden from a superclass or an interface. In our code here, we have a class called building. It contains two methods, renovate and demolish. They both have a printout statement, and it's just a simple class, nothing special here. We then have the home class with one method, paint. We go ahead to extend the building class. I will override the renovate method in the parent building class. Even if we remove the override annotation, it will still override the method. The override annotation helps ensure that the method signature is correct and that the method is being overridden rather than a new method with the same name. Now let's go to the main method and create an object of the class. We can run it and see everything functions normally. Let's imagine we change the signature of the renovate method in the building class. We add a parameter. The override annotation in the home class will give an error. This is because the superclass building no longer has a renovate method without parameters. It's going to look for a renovate method that doesn't have parameter because that's what it seems to override. So, at this situation, there is no override operation occurring. Now remember that the override annotation specifies that a subclass's method overrides the superclass method, and they must have the same signature, that is, having the same method name, return type, and parameter list. If we remove the annotation, the error clears. Why? Java will take the new renovate method as the new method belonging to the home class, with no intention to override. But what happens if we change the signature in the superclass to one without parameters? You will notice that an override operation happens automatically, even without the annotation. You will see the one override text IntelliJ puts to indicate that a subclass overrides this method. And if you hover to the left in the subclass, you will see that it indicates overrides. If we run the program, we see it still works. The difference is with an annotation, the method must override a corresponding method in the superclass. So, here are some benefits of the override annotation. It helps to catch mistakes at compile time. It makes the code easier to read. It can improve the performance of your code. It can help to prevent accidental changes to the behavior of inherited methods. Now, there is another annotation called functional interface. Let's create an interface called car. We intend it's a functional interface. So, we can implement the interface with a lambda expression. Remember, in Java, a functional interface is an interface that has exactly one abstract method. A functional interface can have any number of default methods. That is, methods that have a default implementation, but just one abstract method. If we add another abstract method to the interface, we get an error in the lambda implementation because lambdas operate on functional interfaces. The addition of an extra abstract method means this is no longer a functional interface. Now let's say we hadn't yet implemented the interface, but we wanted it to remain a functional interface so that anyone using it can use a lambda or method reference. This is where functional interface annotation can come in. So, the functional interface annotation is used to indicate that an interface is a functional interface. Now, it is optional to use this. If you don't use it, the compiler will still recognize that an interface is a functional interface if it has only one abstract method. However, using the functional interface has a few benefits. So it can catch mistakes at compile time. So if you try to create a functional interface but mistakenly have more than one abstract method, it will actually generate an error. It also makes the code easier to read because once you see the annotation, you know that this is a functional interface. We have another interface called deprecated. Now we have a class home with two methods, paint and renovate. It overrides the renovate method and it inherits it from the building class. We can create a new object of the home class and call the paint method. Now everything works fine. Let us apply the deprecated annotation to the paint method in the home class. In Java, the deprecated annotation is used to indicate that a class, method, or field should no longer be used. It's a way for developers to indicate to other developers that a certain part of the code is considered obsolete and should be replaced with a newer version or an alternative. When a class, method, or field is marked as deprecated, the compiler will generate a warning when the code is compiled. The warning message will remind the developer that that class, method, or field should not be used. Another annotation used is suppressed warnings annotation. The suppressed warning annotation instructs the compiler to suppress warnings that are generated while the program executes. The suppress warnings annotation takes a string argument that specifies the types of warnings to be suppressed. For example, suppress warnings deprecation suppresses warnings about deprecated methods. You can see the compiler error is no longer present after using the suppress warning annotation.